Well, welcome everyone to the Experiment Spanning Chameleon and Genie webinar. Today's speaker, Paul Ruth, is a senior research scientist at RINC UNC Chapel Hill. He is a researcher in the Network Research and Infrastructure NRIG. He has been a core contributor to the ExoGenie testbed and is currently a co-PI on the NSF Cloud Chameleon testbed. He earned his PhD degree in computer science from Purdue University in 2007. The Chameleon team has simplified the deployment of networks that span Chameleon and ExoGenie using a Jupyter notebook. In this tutorial, you will use a predefined Jupyter notebook to deploy Chameleon direct stitch ports to connect isolated tenant networks at each of the 2 Chameleon sites. It will last about 45 minutes with time for questions at the end. During the presentation, please type general questions in the Q&A box. Jason Anderson, the Chameleon DevOps lead, is joined by other members of the Chameleon team who are on the webinar and will be answering your questions. Thank you and welcome, Paul.
Hi, so I'm just going to go ahead and get started now. It looks like it's a small group, so feel free to ask questions and we will answer them quickly, I imagine. So for this particular tutorial, we kind of expect that you have some experience with Chameleon. If not, you can follow along, but we might not go slow enough for you to keep up. We're going to do this completely from a Jupyter notebook. So if you have experience with Jupyter notebooks, that's good. We will just base everything off a Jupyter notebook and you can follow along there. So to use the Jupyter notebooks, if you haven't already, you just go to jupyter.chameleoncloud.org and you should have a window that opens up that looks about like what you see on the screen now. One of the things that you may or may not know about these Jupyter notebooks on Chameleon is that we have pre-installed some tutorials and some tutorial notebooks for you. If you want to go to the one we're going to follow along right now, we're going to use right now, if you go to the notebooks directory and then the tutorials directory and then double click and then the networking directory, and we're going to follow along on this tutorials direct stitch notebook that I will open right now. So let me make this window a little bit smaller so that we can see as much as we can here. So what we're going to be talking about today is the Chameleon direct stitch connections, and talk a little about what they are, why you want to use them, and then we'll go ahead and deploy some so you can see how to use them. As a little bit of an aside, there'll be lots of examples in this notebook of how to make sort of complicated reservations for resources other than just nodes, and complicated reservations that include multiple types of resources in one reservation, so that you might learn these things as well. So this tutorial assumes that you have used Chameleon before. You have a little bit of an understanding of Chameleon networks and their isolated VLANs, some basic understanding of the CLI, or really more the Jupyter notebooks that are using the CLI, and that you have a Genie account and certificate. Although I can show you how to create one of those during the tutorial if you don't have one. The steps will include, we're going to create a couple isolated networks with these direct stitch ports that I'm about to explain what they are. And we're going to use ExoGenie to connect those stitch ports together. And then we're going to run some experiments using nodes that are using these direct circuits. So a little bit of background on what do we mean by direct network connections. So the regular public clouds like Amazon, AWS have the ability to, as you probably have used before, you can create virtual machines and other types of nodes out in the Amazon's cloud. But they also have this ability to create direct layer 2 circuits that connect your nodes inside of Amazon to things that are outside of Amazon, possibly at your campus. Amazon has their service. It's called Direct Connect. Google has a similar service called Cloud Dedicated Interconnect. Microsoft has something called Express Route, and they're all basically the same thing. What they do here in this picture, which is a little bit small, but you might be able to follow along in your window. In Amazon, you typically create a what is called a virtual private cloud, or VPC, and you can kind of think of that as like a network, or an environment where you have networks that your Amazon instances can create to. Typically, you just have those networks connect out to the internet, so that you can then access those nodes or provide services to something on the internet. But what you can do is then create a virtual private gateway like this one here that's in this picture, and it'll connect to something called an AWS Direct Connect location. So these are places that Amazon hosts in different machine rooms across the country, or really across the world. And if you want to connect your Amazon instances to one of these locations, you can then pay somebody to create circuits that connect your nodes that you have in some machine room somewhere to directly to one of these connections, and then your Amazon instances will be connected directly to computers that you own or in some machine room somewhere. So that seems really complicated, like you wouldn't be able to do it, but there's actually some pretty clever ways that we can provide this service to you, or so that you can do this. You might ask why you would want to use these direct connections. Well, a lot of it is like, what's the benefit of these? I write that down here somewhere. Yeah. A lot of what these are used for are things like extending a campus infrastructure into the cloud. So you might have like a set of compute nodes, like a computational facility at a university or something like this, or a business, and you are limited because you have, however many compute resources you've purchased and installed in your machine room. But there might be times when you want to increase that size temporarily, but you want all your nodes to seem as if they're still coming from your machine room, or still in your machine room. And what you can do is create these direct layer 2 connections between your machine room and your nodes there into Amazon, create nodes on Amazon that look just like your nodes in your machine room at your institution, and provide services to either your campus or externally to the internet that appear to be coming from your campus, even though they're actually in Amazon. So that's one thing people do with this, just to sort of expand their capacity for peak demand. Other things that people want this for is if you want to increase your network performance between your campus or your actual machines that you own and nodes that you're using inside of Amazon. Instead of using the internet, you could use one of these direct connections to connect into Amazon, and you will get higher bandwidth, possibly lower latency. And then another important thing is that it's secure. It's more secure because you're not using the internet to connect these nodes together. So these networks are not exposed to the internet and can't be attacked by random other users on the other side of the internet. So this is an important thing that you might want to use this for. Educational and research institutions can do this. You can learn about different ways that big institutions and internet service providers interact with each other. So you can experiment with network peering. So you can stand up nodes inside of Amazon, and you can peer them with nodes you have in your department. And you can do this just to play with it as a student so that you understand how it works. You can experiment with different types of wide area networking performance issues and try to optimize those if you want, or even use non-TCP IP protocols, because at this point you don't really need IP for some of these connections. So this is not really possible with the public clouds, but as we'll see, we have these direct connections to Chameleon, and they don't require you to use any IP or TCP. You can do more interesting things with them. So kind of a little bit modeled after the way Amazon does this with their direct connect, we have developed something for Chameleon called Direct Stitch. What this is it creates direct layer 2 connections between your networks inside of Chameleon and remote campus facilities, and it's just like the way Amazon does it, except it's implemented a little differently. In general, what this does is when you create a private and isolated VLAN inside of Chameleon, where you basically are connecting and creating a network switch. This switch may be controlled by you via OpenFlow, or it may not, and there's just a regular VLAN. Both types of networks can be stitched externally to the remote facilities. But once you have your isolated VLAN, you can connect nodes to it. Those nodes can have access to the internet via the regular NAT interface that you typically get. But then optionally, then what you want if you want to use direct stitch is you want to have a connection that in this case goes to Internet 2's advanced layer 2 service or ExoGenie, and you can use either Internet 2 or ExoGenie to connect a remote campus facility to your Chameleon nodes. And then of course this remote campus facility, just like in the Amazon case, it could be your campus or machines that you own in your machine room. And that's how that works. So for this tutorial, and what we're gonna do in this particular example is show you how to create these networks and nodes connected to them, and then how to utilize these direct stitch, the direct stitches to connect to a remote facility. Now, because most of you don't have a remote facility, what we're going to do is we're going to create two facilities, one on either of the Chameleon sites, and we're going to connect them together, like this picture down here. So we're going to create a network switch in Chicago and connect some nodes to it, and we're going to create a network switch in Austin and TAC, and then connect some nodes to them. And then we're going to use ExoGenie in this case to create a circuit between the two that will allow these two facilities to communicate. And you may want to actually just do your experiments like this using both Chameleon sites, but you may also, if you have your own campus facilities, like whatever infrastructure you have at your facility, you could also connect it to your Chameleon nodes, provided that you have set up your campus facilities to connect to Internet 2 LTOS and or ExoGenie. And if you want to do that and you don't have that set up, you should contact us and we would be more than happy to help you set that up so that you can connect to your own campus facilities. All right, so how do we do this? Well, in this notebook, you're pretty much just going to have to run everything that's in this notebook, and this will happen for you. So this is a simple example, but then of course, if you're doing a real experiment, you probably want to make a copy of this notebook and then customize it to do whatever you need to do. So let's get started with running some things. And well, there's actually not that many people, so I'm not going to worry about that. I was going to say, don't get too far ahead of me, because you might steal the VLANs that I need to run, but there's not enough of you to do that, to get in the way, so that's okay. Do we still have the same number of people? Mm-hmm. Okay. So in this notebook, there's a bunch of variables. Here's some explanations of what they are. Most of them are just the typical things that you would have to set in your Jupyter notebook. So in this case, I'm setting my project name. Your project name may be different than this. Use whatever project you have access to. I'm putting my SSH keys in here. So this is I don't know that this notebook actually uses them, but it's convenient if I want to quickly modify this notebook to do something more. I might want my keys in a variable. And here, what I'm going to do is I'm going to set up the subnets for the two networks. So if you remember, see if I can get this all on the same screen. The way this is going to work in this picture, we're going to have two switches, one in Austin and one in Chicago, and they're going to have to be on the same subnet. So we're going to have to make the one subnet span both of these sites. So in this case, what I'm saying is that the subnet I want to use is 192.168.100.0/24. And because both sites are going to allocate IP addresses independently, what I have to do is set each site to allocate IP addresses that are in that subnet, but allocate them from a disjoint set of IP addresses. So in this case, I'm saying University of Chicago nodes are going to be 192.168.100.10 through 100.19. And the ones attack are going to be 100.20 through 100.29. And you can set that to whatever you want them to be, whatever you want that to be. I'm also going to set up a resource prefix. So these are just names. So when I name things in Chameleon, I usually try to use unique names so I can tell what's mine and what's somebody else that's in my project. In this case, I'm saying the resource prefix name is going to be my login ID. And when you run it, it'll be your login ID based on this $user variable. It's going to be tutorial, and then it's going to have today's date. So I can tell which one, if I have an old one in there that I ran yesterday or something. I'm also going to use my Genie PEM file. So this is my certificate that allows me to use Genie. This will be used like in one of the very last steps. So in order to create the stitch. If you don't have that, we'll show you how to do that before you need it. But I just put it in this variable up here so that it's there when I need it. So like any other Jupyter notebook, to set these variables, I just hit play, and now all these variables should be set in my notebook, and I can continue on. So now what we're going to do in the first step of this is I'm going to create the isolated networks, and the first thing I'm going to do here is create the network at University of Chicago. So again here, I'm going to use my resource prefix name. So this is just the unique name that has my user ID in it, and I'm going to add a little bit to the end of each one. And these will be the names that I use for my isolated VLAN, the subnet, the router, and the network when I create all of these things. So I'm going to hit play, and now I have all those set in a variable. All right. So now, as of yet, oops, let me clear all my outputs because I haven't done that yet. And then I will rerun this real quick, and that way we won't see the last time I ran this. So the next thing I'm going to do is actually create the network. But I'm going to do a bunch of other things at once. So this is kind of a complicated step here. And I'm going to walk through it here and show you what I'm doing. So the step is actually this Blazar command. So this step right here is actually creating a Blazar release. And you've probably done this before, maybe through the GUI. But in this case, I'm creating the Blazar release with the command line interface inside of my Jupyter notebook. And this is a little bit different because it's actually creating 3 different types of resources at the same time. So in this case, I'm creating one Haswell node. So this is just going to be the one node that I connect to, that I reserve so that I can run. So I'm going to create a network, and I'm going to connect this Haswell node to that network. And I'm just going to do one. You could do more if you want, but for this particular tutorial, I only need one, so that's what I'm going to use. I'm also going to reserve a floating IP, and these are the public IPs that I can use to connect to my node. You may have experience doing this before, and you may have done it without, like, where you've just allocated a floating IP to your project. We're moving towards a workflow where you have to actually reserve the floating IPs, because if you've done this before, you've probably run into the case of we've run out of floating IPs, and so we have to go try to reclaim them and these kinds of things. So what we're doing is actually moving to a workflow where you have to reserve them, and if everyone has to reserve them, then hopefully they'll be more available for regular users. The next thing is I'm actually going to reserve the network. So this is actually one of the interesting steps here. So there are, in fact, exactly 10 VLANs that are connected from each site to Internet 2's L2S service. And specifically, this one connects to ExoGenie. So what I'm reserving here is an isolated VLAN. It's a network of type. We're going to reserve a network, and it's going to have the name that I set in the previous cell here, and it's going to have the properties that it's going to be a physical network, and it's going to be of type ExoGenie. So this is a special kind of VLAN, of isolated VLAN that is pre-plumbed all the way to ExoGenie. So if you have used isolated VLANs in the past, you've probably either done it through the GUI, or here in this step, you type physnet1, and what that gives you is a VLAN that doesn't go to ExoGenie, it just stays within the one site. But the key here is that we're asking for a VLAN that actually goes to ExoGenie. And once we allocate that, then we can use ExoGenie to connect to it from the outside. And then, of course, I have the start and end date, which I've set to 2 minutes from now because it's basically now, and then ending tomorrow. And then, so if I run this, let me run it, and what we'll see is it should make this reservation. It prints out, this is just like if you ran on the command line interface. And in a minute, I should have run this earlier because then we could have waited. And then here it's going to print out the reservation ID that I get and the node reservation. So this is the reservation of the whole lease, and this is the reservation of just the node. And we're going to need that later when we want to start our node. So we see what we made here is a big reservation that has 3 parts. They're all pending right now. The first part is the network. Second part is the host, the Haswell host, and the last part is the floating IP. And in a couple minutes, these will be created and we'll be able to use them. And this next cell that I'm going to show here is actually going to query the network that was created by that Blazor, the Blazor reservation that I created. Is going to create a network, and it's going to get the VLAN that network was assigned. So when you create one of these ExoGenie stitchable networks, it's going to get assigned a specific VLAN, and you need to know that VLAN so that you can go to ExoGenie and specify which VLAN you want to connect to. So now we have to wait a couple minutes. I actually turned off my email so that it wouldn't get interrupted, but usually that's how I tell when this is successful, is because it sends you an email saying that it worked. I'm just going to try to run this. Okay, so it actually worked. So here, what it did is it queried for the VLAN, and it got VLAN number 3293, which is fine. The range is 3290 through 99, I think. So this means this is a direct stitch VLAN that goes to ExoGenie from the University of Chicago rack. And the floating IP that I was assigned was this particular floating IP, which happens to be a public IP at Chicago. And that's great. Okay, so now what I have is a network, an isolated VLAN on the University of Chicago Chameleon rack that is on VLAN 3293, and that happens to go to an ExoGenie stitch port, which we'll talk about later. What I need to do so that I can use this at all is I need to do the regular thing that you always do when you create an isolated VLAN, which is you need to create a subnet. And this subnet is going to use the subnet that I assigned in one of the first cells, and it's going to allocate IP addresses from the pool that starts with the IP address that I said it should start with and ends with the IP address that I said it should end with. So this is .100.10 through .100.19, I think. And I want to have DHCP, and I want to have this be assigned, the subnet be assigned to the network that's the name of the network that I specified previously. And then I need to create in order to have this access to the internet, I want to create a router, and I want to link that router to the subnet that I just created, and then I want to link that router to the public gateway that lets you get to the outside. And then when that's all done, this will be ready for nodes. So let me hit play here and we'll run this. So this is just exactly the same as you would do it as if you're creating a regular isolated VLAN that wasn't a direct stitch connection. So here's it creating the subnet, and that was successful. It creates the router, that's successful. Links the router, and links the router again to the gateway. And now it says it's ready for nodes. Okay, so what I have now, if we go over here and I look at something you've been familiar with, if I look here in leases, I should have this lease that says period tutorial July 16th UC, which I was just created and it's active. If I look at networks, I should have a network. There's probably a bunch of networks here. So this is the period tutorial July 16th network at UC. And it has this subnet assigned to it. And if we dug deeper, it's connected to a gateway, and it has all the IP addresses, right? So now we have a network that we can use and create nodes on. So the next thing I'm going to do in the Jupyter Notebook is to run this. So here's the CLI command that will do this. In this case, I'm saying OpenStack server create. When I create just a regular CentOS node, let me hit play right now because it takes a while to do this. It's going to create a regular CentOS 7 node with the key that I specified previously. It's going to use the reservation that I created in this particular notebook, default security groups, and then I'm going to use the network that I just created, and I'm going to name the node the name of the node, and that's here. It's a resource prefix node, right? So here, this is creating a node. It should be connected to that particular network that I just created. We can go look over here and see if it's being created. It probably is being created, we hope. So we have now, oops, it says error. Why does it say error? Did I do something wrong? What did I do wrong, guys? That was watching.
Log.
What's that?
Log.
At the very least, I should shut this down. Close that one. It might be just that I. Usually what's wrong when you do that is it has the wrong, let me try this one more time. If it failed like immediately, if it fails again, it might be that the reservation is bad. Like sometimes you get a bad node or something like that. I ran this 3 times earlier today. Let's see what happens. Huh. No valid host was found. I don't know if there should be one. Let me see. Let me make sure. If the reservation includes a lease, it says it's active. And down here,
Max mean 1.
should be 1. It says it's active. It says there's 1. All right, I'm just gonna go back here, and this isn't too bad. We can just go to compute instances. I'm gonna clean this up and restart the reservation just to make sure it works, or to get a better one. No, I'm just gonna clean the reservation up. And I'm gonna go back to my Jupyter notebook and rerun some things. And when I get to the step where I need to create the reservation, I'm going to, or like here, I'm gonna ask for more than 1 node, and then maybe we'll get a good one. And then, all right, if we could finish in time. And this should take a couple minutes to run. So if I try to run this too early, it'll say there's no network found for the network we're looking for. And that's because the reservation hasn't been instantiated yet. But it should take just a couple minutes. We should be able to go over here and see what state it's in. Is anyone asking questions? Are you guys answering questions?
Nobody's asking.
No. All right. Okay, now the lease is starting. In a minute, it should be active. All right, so now I should be able to rerun this cell. And I got, that particular VLAN, that particular IP address. And now let's try to run one of these and see what happens. Well, no, this is creating the subnet in the router. And we'll try to create the node. And let's see what's happening here. Okay, so now it's building. I think maybe I just got a bum node in the previous try. So now while this is trying to boot, which could take 7 to 10 minutes, I'm gonna move on and do, so if I give it just a few seconds longer, so it's in spawning. So now what I'm gonna do in this particular step is it's OpenStack add floating IP to the node. So now this will actually add the floating IP to the node, and we should see, once that's done, we hit instances again. Now this floating IP is right here, associated with this node, and I'm going to cut and paste that IP address to this terminal window here and try to ping that node, and when that ping starts working, we'll know that that node is available, is up. All right, so all we have now is, just to recap, what we have now is a isolated VLAN at Chicago. It has a VLAN that's available for stitching on ExoGenie, but we haven't stitched it yet. And we've just tried to create a node that's connected to that network. Now what we're gonna do, kind of quickly, because we're got delayed a bit there, is we're gonna do exactly the same thing, but on the TAC site. So this is the same code as we had in the previous section, except it has the region name TAC instead of Chicago. And we're going to just create the exact same everything, basically. I'm going to increase this number in case this doesn't work for some reason. And here we go. So we're going to create the reservation of the nodes, the floating IP, and the network that is also stitchable to ExoGenie. So now, and then the start and end date will be now and tomorrow. And then we will get our different reservations. Okay. All right, so now we're making our reservation. And then this particular step is the one where we have to find the VLAN numbers, which isn't assigned until the reservation is active. So it says there's no reservation yet. So if we go back here and we switch over to the TAC side, we should be able to watch our reservation get built and see when it's available. So I got some old ones in here that had errored and haven't cleaned up yet, but we can see that our one from today is pending, and it'll take a couple minutes for it to instantiate. And meanwhile, our node at Chicago is starting to boot. Still no questions? Once this gets started, then I will move over to explaining a little bit more what we're doing. Come on, you want to boot. Okay, now it's starting, and then it should be active in a second. Okay, so now we're active at TAC as well. So we should be able to rerun this particular cell, and we will see that we got VLAN 3501, and that's a good one because the VLAN tags between 35, I think it's 3500 and 3509 are the stitchable ones. And we get the floating IP here is the public IP, and we'll continue on here to do exactly what we did. Is we're going to create the subnet, same subnet as before, because these subnets have to match, so that because we're going to stitch at layer 2 between the two sites eventually. And in this case, we're going to have TAC allocate IP addresses from a different range than in Chicago, and that should work fine, so they don't overlap. Now it's ready for nodes. Oops, I just hit to rerun the same one, but that's okay. It's not going to work, but I just reran that cell, and that's probably not a good thing. Let's see what happened here. It looks fine. Okay, so basically it's just going to error, but that's fine. Okay, now I'm going to run to create the server at TAC connected to this new network that I just created. And as soon as we see that it's booting correctly, yeah, and so there was so these are bare metal nodes, so that's why it takes 7 to 10 minutes to create. But if you're familiar with Chameleon, then you should be familiar with that, I think. So let's just make sure that the compute node is on its way. So it looks like it's building. It's connected to the network that I just created. And we are going to assign a floating point to the floating IP to the TAC node. And once that's ready, I should see that yes, of course, it has this IP now. I'm going to grab this IP address, and I'm going to use my other window here that somehow went out of the screen, and I'm going to try to ping that node, and then we'll see that ping will work once the TAC node is up. Okay. So now what we've got here, and I'm going to scroll back up because the next step is to actually connect these together. I'm going to scroll back up to the picture we had before near the top. So what we have here is this picture, except we haven't created this stitch between the two. So what we have is two VLANs, one at Chicago and one at TAC, and they both are pointing towards Internet 2's L2S connection, but there's nothing connecting to the other side of that. They're available to be connected to, but they're not connected. And we have two of them, one on either side. And what we want to do now is connect them together. And if you were doing this for yourself, you might have your own L2S account, in which case you could just use the L2S service to connect your nodes to anywhere on L2S that you also have access to. Since you probably don't have an L2S account, you want to use some service like Genie, or an ExoGenie specifically in this case, to connect to those for you. And then what that allows you to do is to connect to the limited number of places that ExoGenie can get you. So that's what we have going on right now, is these two sites, two separate VLANs. They're pointing at L2S, but nothing's connected on the other end. So one way to do this connection is to use, like if you've used Genie before, ExoGenie before, you can just use the regular ExoGenie tools and create a stitch port in your ExoGenie topology request. And if you do that, it'll connect to your network on Chameleon. But what we've done, if I scroll down all the way to the bottom, is we've created a simple tool inside of the Jupyter notebooks that you have available on Chameleon. And with this simple tool that we're calling ExoStitch, it'll actually create a stitch port from UC on the VLAN that you were assigned here. So this is the VLAN that you were assigned at UC, and this is the VLAN you were assigned at TAC. And what this command will do, and it's available already in your notebooks once you turn this on, is it'll contact ExoGenie and create this stitched link between the two sites. And the only tricky part here is that it has to know you have to have a Genie account, and it has to know who you are and which Genie account to use. So you have to pass in your Genie PEM file, which you can get as a Genie user. So since we're waiting for those nodes to boot still, I'm going to go through a little bit how to do that. So if you go to portal.genie.net, and here, if you want to, you want to just create an account, and you can do this. Anyone can do this as long as you have an in-commons from an in-commons university. Okay, we can see down here that one of our nodes is almost ready because it started to ping. So that's good. We're getting closer. But if you want to use Genie, for you, it'll actually have you initiate a new account. For me, I can't actually see that because I've already created an account, but I can log in to my Genie portal using my university, my UNC credentials, and you will use your own credentials for your university. That's how it works. And I have to use LastPass, but it'll do it for me. And it logs me in. And now this is my portal, and all I really need from this is my my Genie PEM file. So if I go to Profile, and you go to SSL connection, and you can say download your SSL certificate and key. And if I were to click on this and download my certificate, it actually downloaded my Genie PEM file. So once you create a Genie account, you just have to go to this page and download this PEM file. Then you need to go to your Jupyter Lab notebook, and you need to upload your PEM file. So if you look here in my home directory, I've actually put my Genie PEM file here, and you can do that with just this upload button right here. You upload any file you want. So my Genie PEM file is sitting in my Jupyter notebook, and up here at the very top in this notebook, I have, if I find it, set the variable that points to that PEM file. And now, since my PEM file is in my notebook, and there's a tool in the notebook that will allow me to create these stitched links on ExoGenie, as long as I pass in my Genie PEM file. If I go down to the bottom, I can explain sort of what's going on here. So this is just going to print out the 2 different VLANs that we were assigned. Hopefully they match the ones that we saw earlier. And then we're going to call this ExoStitch create. So we're going to create a stitch link from University of Chicago on VLAN, whichever VLAN we were assigned. And then we're going to connect that to the stitch port attack on the VLAN that we were assigned attack. And we're going to use the Genie PEM file that I had previously uploaded. And you can just do this with your Genie PEM file when you want. I'm not going to do this yet because I want to show you it, what happens when it's created. Hopefully this node is almost done. We're a little bit behind because of that error we got. So 6 minutes. So probably now I can log into this node. So let's try to log in to the node at UC. So now I'm logged into this node. Hopefully you can see that. It's not too low. Let's see. And you see that we just have, this is a regular node, looks the same. It has got this IP address, which is 192.168.100.12, which is the address of the one that's at Chicago. And of course, if you remember right, that's actually between 192.168.100.10 and 100.19. It was just randomly assigned one of the ones in the middle. I don't know why I picked 12, it just did. And then the other one that's going to be attacked will be .23, so they won't conflict, but we did that intentionally. Let me make this a little bit smaller. All right. Hopefully people have a little extra time because we're going to go over a bit. All right, so this says my node attack is active. So we're almost there. It should almost be working. You can see in my node at Chicago, I should be able to can ping myself, obviously, 12, which is my own self, but I should, not yet, but soon, I will be able to ping 100.23. But I have to create my link for it, link to go across there. Come on, start pinging. All right, this should be working soon. Is it not working? Oh, it's working now. So the node is now up, and we're pinging it through the new network that we created from the internet. Hopefully I will be able to SSH to it. If it doesn't work right now, it takes a couple more minutes after it's pingable and we can log in. Okay, now we're in. All right, so we can see now that this particular one, it has 192.168.100.23. And in theory, we should be able to ping across these because there are 2 stitched links, but we haven't created the link yet, right? So here you can see that I can try to ping it and it doesn't work. But if I go back over to if I use the public internet, I can ping it from the other side. So this is pinging from Chicago to TAC across the public internet, and we're getting about 32.6 milliseconds of round trip time. And what I'm going to do now is I'm going to turn this ping on that is going over the private network that doesn't work, go back to my Jupyter notebook, and inside of this command right here, I'm going to actually use Exogeny to create the layer 2 circuit. And as soon as that becomes available, we should see the ping start to work. Oh, that one more thing. Okay, so I restarted my notebook earlier and deleted one of my keys. But so what's going to happen here is it's actually contacting Exogeny. If I go back and I look at my Exogeny tool now, which you might want to become familiar with, I can see this Exogeny slice available, and it's starting to boot it, and it's not quite available yet. So this is now having Exogeny create the circuit between my 2 sites, and this should also take a few minutes because it actually has to go out and contact Exogeny, and then Exogeny has to contact the L2S service, and then it'll create this circuit between the 2. So now Exogeny has finished its part. It thinks it's up. L2S is in the process of putting the stitched link together, and we should see in a couple minutes this ping should start working between our 2 sites. And just to recap again, what we're doing, if I go up here near the top, is I'm actually creating this circuit between that VLAN and that VLAN through Internet 2 and Exogeny. And it's in the process of being built. So now we can see it's now pinging. So this circuit has been created. So if you can see now I can ping from one node to the other using either the private IP addresses 192.168.100.23 and 12, or using the public addresses. And if you see here, when I do it using the private address, I get 30.7 or 8 milliseconds. When I go over here and switch to the public address, we're getting 32.6 milliseconds. So we're actually decreasing the latency a little bit, not too terribly much, but a little bit. And with maybe even more interesting is if we look here and we say trace route, and we want to see the path that these two are taking. If we do the path of the public internet, we'll see a whole bunch of router hops. So what this is doing is actually finding all the routers in between the two nodes. And if I use the public internet, we see, I don't know how many hops it is, 15 it looks like. But if we use the private network, the circuit that we just created, we do trace route, we can see that it's just one hop because it's on the same subnet. So these are actually two nodes, one on either of the Chameleon sites, connected both through the public internet and via direct circuit that we connected between the two. And you get different amounts of latency. I was gonna go through some stuff with bandwidth testing, and I'll just give you a little hint about it. But we'll see that we can get different amounts of bandwidth as well, because you can get, across these circuits that you're creating, you can get up to 100 gigabits of bandwidth in aggregate, although each of these nodes only has a 10 gigabit network card. But if you try to get 10 gigabits of network bandwidth via the public internet, you're gonna have a hard time doing it. You probably won't even be able to do it because of the way the internet's connected to Chameleon. But if you use these private isolated circuits, you can get as much bandwidth as your hardware allows. So that's important. You will need to, just to give you a hint, because we're, about out of time and we wanted to leave some time for questions. In order to get high bandwidth, you're going to want to tune your nodes, and this might be the experiment that you're experimenting with, is tune your nodes for high latency, high bandwidth connections. And one of the places I recommend going is this fasterdata.es.net. If you go to this website, this is a U.S. Department of Energy website, and they have a lot of information about getting high performance networks working. And host tuning is a really useful link here. If you're host tuning Linux, it'll actually show you how to tune your host to get high bandwidth. Mostly what you want to do is drop this in your system config file and then restart that. And you will have things like jumbo frames and different amounts of TCP configuration, and you'll be able to get high bandwidth on your connections, that you won't be able to get otherwise. So you go back down to the end of my tutorial here. So this command right here, it creates the circuit. The next thing I suggest you do is to ping and find the round trip time, which we did. Then I suggest that you try trace route to see how many hops you get between the two sites using each of the different paths, which we did, and we saw that the circuit was actually faster. And then you can use iperf3 and you can try to test the bandwidth and see how much bandwidth you get through either side, and you'll see very different amounts. And it's interesting to try to tune it in different ways and figure out how much bandwidth you can get. A couple other useful commands with this ExoStitch is, one is just the status. So I can just run status here and it should just say, oh, it's up and active, right? So that's what we see here. So everything's active and stable, so that's great. If you had some errors, it might actually say some errors here that might be useful. And then when you're done, you want to delete your Genie stitch, so you can delete it. I won't do that yet in case we need to use it. And then down here at the bottom, you can actually delete your Chicago reservation of a node, and then you can delete your TAC reservation of the node, and then you can delete your the Genie stitch. Yeah. So that's what I have for today. This shows you how to create two isolated VLANs on one in Chicago, one in TAC, and connect them together using a dedicated isolated circuit. So do you have questions? Should we just turn on the volume because there's so few people?
Here, I'll just allow everyone to talk.
Yeah. So you can just talk if you want because there's not that many people, so you won't be talking over anyone. It looks like I have a little warning here in chat. Yep. All right. So it's just Jason telling me to make a new lease. So is anyone on there? I know.
Yep, we got 2 people, Erica and Jay.
Are they talking or are they?
I think Erica's about to talk.
All right. Hello.
Hi, yeah, I'll try
Oh.
later.
Yeah, we can hear you.
Yeah, I mean, I will try later. I didn't follow along, so.
That's fine. It's a little fast.
Paul, I have a question. So if the two networks, the subnetworks are controlled by different users, can we stitch them together?
Yes, you definitely can. You definitely would have to coordinate with that other user to make sure your subnets don't overlap, or your subnets do overlap, and your allocated IPs don't overlap. So you'd have to coordinate with that other user. But yeah, for sure, that's definitely something you can do.
Cool.
One or the other user will have to own the circuit, but the two different Chameleon users can own the 2 networks at the different sites. Yeah. Is there any other questions?
Also the Jupyter notebooks. I mean, perhaps I missed that. Where is the Jupyter notebooks now? Right now?
If you go to if you have a Chameleon account, if you just go to jupyter.chameleoncloud.org, and it'll ask you to log in. If you use your Chameleon login and password, it'll create a Jupyter notebook container for you, and inside of that will be pre-installed this notebook that I just ran. So you should be able to just find it. It should already be there.
Got it.
So I can just edit them, right?
Yeah, you can edit it.
They'll be in my own folder.
I suggest a little bit that if you want to edit that notebook, that you make a copy of it and then edit the copy, because that is actually checking out of a GitHub repository, and if you want to make sure it doesn't ever get overwritten, you should probably just make a copy and edit the copy.
Ah, got it. Okay.
I guess if there's no more questions.
All right, well, thank you, Paul, for presenting this talk today, and we appreciate your time and that of our attendees. Feel free to join us in 4 weeks for our next webinar. We're doing an introduction to Chameleon, or pass that along to someone that may be interested, and that will be on August 27th. So thank you all, and have a wonderful rest of your day.
Thank you. Bye-bye.